Welcome back, and we're still in Chapter 2, which is a review chapter for us reviewing this fundamental mode of analysis of supply and demand, these fundamental constructs from which we'll explore all other things in Econ 201. And in the last lecture, we really just looked at what these relationships are. Today we're going to unpack the mechanics of these relationships by revisiting what we learned in Econ 101 regarding elasticity. And elasticity is a stupid, jargony word, but all it means is sensitivity. So last lecture we talked about how you are all suppliers in the marketplace and you are all demanders in the marketplace. And what that means is you all have willingnesses to bring to market as a supplier, you all have willingnesses to pay as a consumer, as a demander. But one of the mechanics that we need to explore is how sensitive you are to the various price changes that influence your willingness to pay or your willingness to accept. And that concept of sensitivity in econ is elasticity. Right now we're talking about price elasticity of demand, but there are many, many elasticity concepts because you can be sensitive to anything. Changes in price are certainly one of them, but you can be sensitive to the price of related goods. You can be sensitive to how much money or wealth you have. You might even be sensitive to external things like the weather. But as long as we understand the core elasticity concept, we can then expand on it and consider other forms of elasticity as well. So let's start with that core elasticity concept, price elasticity of demand, which again is the percentage change in quantity demanded resulting in a percentage change in price. In this case, a 1% increase in the price of that own good, own price elasticity. We write it as percent change in quantity over percent change in price. We can also devise our percent change relationship as change in quantity over change in price over price. By doing a little bit of arithmetic, we can come up with the expression price times change in quantity over quantity times change in price. Let's explore what this looks like on a linear demand curve, by which I mean a demand curve that's a straight downward sloping line. And this is one of those cases where economists are going to try and lie to you, because we might be comparing elasticities of two different goods, say the elasticity of copper relative to aluminum. But what we're going to see is that on a linear demand curve, we're going to see every possible price elasticity ranging from negative infinity to 0, including unit elastic at the midpoint. How does this work? Well, the price elasticity of demand depends not only on the slope of the demand curve, but also the price and quantity. In other words, where you are on that particular demand curve. So let's consider this particular demand curve where we have an equation for the demand. Quantity demanded is 8 minus 2 times the price. So what that means is near the top of this demand curve, when say the price is $4 and we are not demanding any of this good, price is relatively high and quantity at 0 is relatively small. So our elasticity, our percent change in quantity demanded over our percent change in price, is going to be very large in magnitude. In other words, we're very sensitive to price changes. So at this choke point, this price of $4 where we're not in the marketplace, a very small change of price which brings us into the marketplace is going to have a large effect. As we move down the demand curve, this magnitude of elasticity, this price sensitivity, becomes smaller and smaller, where it's unit elastic at the midpoint. So a 1% change in price is equal to results in a 1% change in quantity. And by the time we intersect the quantity axis, we're completely inelastic. We're not sensitive to price changes at all. What this implies is, in addition to mathematically describing this concept of elasticity, this concept of price sensitivity, we can also qualitatively describe it, ranging from infinitely elastic in this case to completely inelastic on the next slide. So let's take a minute and describe what infinitely elastic demand looks like. And we draw it as a flat demand curve. You see it here, flat. And what it means is any tiny change in price, any infinitesimal change in price leads to enormous, perhaps infinite change of demand. We've seen examples of perfectly elastic demand in Econ 101 when we considered things like perfectly competitive markets. So something like the market for wheat, where one bushel of wheat tends to look exactly like the other bushel of wheat. So if you're a farmer selling wheat, and I'm a farmer for selling wheat, and I try and raise my price above the market price, suppose I try and price my wheat up here, no one is going to buy my wheat. They're all going to buy it at this competitive and prevailing market price of P star. Consumers at this competitive and market price of P star will buy as much as they want at this price. Similarly, in a perfectly competitive, perfectly elastic demand situation, what happens if I am a farmer selling wheat and I price it here below P star? Well, I can't do that. I'm going to go out of business. So what we see is a completely flat demand curve with a prevailing market price of P star. For any higher price, market demand immediately drops to zero. For any lower price, market demand increases infinitely, and chances are the producer can't produce that much. To recap, what this means qualitatively is that we are infinitely sensitive to price as consumers. On the other side of things, we can qualitatively consider perfectly or completely inelastic demand. What that looks like is a vertical sloping demand curve, where no matter what the price, you're still demanding the same quantity of that good. We tend to think about addictive goods when we consider inelastic demand, goods to which you are not price sensitive. So things like cigarettes or crack cocaine. In fact, our good friend Scott Cunningham has a paper where he empirically estimates the elasticity of methamphetamine using changing prices in other street drugs, and he finds that its elasticity of demand is minus 0.2. So not perfectly inelastic, but still very highly inelastic. Users of methamphetamine are not particularly sensitive to changes in the price of methamphetamine. To reiterate, what perfectly inelastic demand means is that consumers will buy a fixed quantity of that good regardless of the price. Again, we can think of not just own price elasticity of demand, but other elasticity concepts as well, because all elasticity is a sensitivity. So we can think of something like income elasticity. How sensitive is your demand to changes in your income? Or cross-price elasticity. How sensitive is your demand to the price of other goods changing? And this is where we can start to unpack some of those supply and demand concepts we reviewed in the last lecture. So yes, we know that your demand can shift due to a change in income, but what does that look like mathematically? Well, in the case of an inferior good, where an increase in your income leads to a fall in demand, that looks like a negative income elasticity of demand. A positive income elasticity of demand means that an increase in income leads to a rise in demand, thus a normal good. From our definition of normal goods, we can unpack it further and talk about whether goods are necessities or luxuries, whether the income elasticity is positive but less than 1 in the case of a necessity, or positive and greater than 1 in the case of a luxury. And we can start to tie these conceptual and these qualitative definitions to what they look like mathematically in terms of percent changes. Similarly, in terms of cross-price elasticity, we have this conceptual notion, this qualitative notion that demand changes due to the price of related goods, whether they're complements or substitutes. But now we can think about how a percent change in the price of one good affects the percent change in our demand for another good, our quantity demanded for the other good. So take a minute and think about how that might work mathematically and what that means for our qualitative interpretation. So if our cross-price elasticity of demand is negative, for instance, the demand for cars and the price of fuel, we might have complementary goods, in which case our cross-price elasticity of demand will be negative. Alternatively, if our cross-price elasticity of demand is positive, we're going to have substitutes. Again, think about hamburgers and hot dogs. However, we can also have cross-price elasticities close to zero, where the goods might not be related at all. Think about, to split the example I just gave, the price of hamburgers and the price of cars. Finally, we consider not just these differences in sensitivity concepts and elasticity concepts, but also where we're calculating them, whether we're calculating them at a point or over a range of possible prices. And for those ranges of prices, we'll consider arc elasticity, the equation for which is given here. In class, we're going to go over more examples about these elasticity concepts, but we're interested in how dynamic they are, how they change. And one of the things that might change our relationship to price, our sensitivity to price, is the time frame we're considering. And in the long run, demand tends to become more elastic. We tend to become more sensitive to price over time. Take a minute to think about why that might be. Well, this is not an exhaustive list, but we can think about a bunch of different reasons why our sensitivity to price might increase in the long run. Let's take driving as an example. If the price of gas goes up overnight, I still need to get to Sweetbriar tomorrow. There's not much I can do. But as my time frame expands, I might start thinking about alternative routes to Sweetbriar, whether it's me purchasing a bicycle, or me carpooling with friends, or maybe me investing in a fuel-efficient vehicle. Our technologies change, our choice sets change, and our ability to plan changes. And as a result, our long-run demand curve will flatten over time. Note that the example on the last slide was true for a non-durable good like gas, but might not be true for a durable good, where over a longer period of time, our demand tends to become less elastic. We become less sensitive to price. And the reason for this is because durable goods break down. So whereas right now, I don't require a new refrigerator, and I can be very sensitive to price changes in fridges where if they go on sale to an extreme degree, I might purchase one planning for the future. If they're not on sale, or even if their price increases, I can put off that purchase. In the long run, as my fridge gets more and more wear and tear on it, becomes more and more to breaking down, which it will eventually, I become less sensitive to those price changes. And if my refrigerator was not working right now, I would be at Home Depot buying a new fridge. In short, durable goods have the opposite elasticity expectations between the long and short run. To summarize, elasticities differ depending on time frame and also differ depending on the nature of the good. Most goods become more elastic in the long run. But for durable goods, which are rare in terms of our consumption, but very important in terms of our consumption, we tend to see the opposite. Thanks so much, and I look forward to seeing you all next week when we start to unpack the nature of the demand curve and talk about consumer behavior.